All right, welcome back, ladies and gentlemen. So now let's go ahead and work on the processes for classifying conic sections. Now, typically we can go ahead and classify these since these are in general form, but what I wanted to do is just practice working on converting this to their standard form via completing the square. So therefore we can classify the conic sections in the form that is a little bit more it's easier to identify or differentiate them between the different conics. So in this first example, hopefully we can see here that this is exactly a parabola. There's only one term squared. However, if we want to go ahead and put this in our standard form, what we're going to want to do is put the x's over here on the other side. So I have y squared equals here a negative 6x minus 18. Now, when we're writing this in our, if you notice in the conic sections, we had that 4p. So what we're going to want to do is we're going to want to factor out anything. We want to make sure our coefficients for our x and our y squared are going to equal 1. So what I'm going to do in this case is I'm actually going to factor out a negative 6. So by factoring out negative 6, I'm going to be left with an x plus 3. What that is going to do is that's going to give us our actual value of our vertex, which in this case would be negative 3, 0. You can see I'm not subtracting anything by y, so the k in this case would be 0. But it's very important to make sure you factor that out, so therefore it has a coefficient of 1. And again, when we look into the parabola, we'll look into that a little bit deeper. Now this next example, if you recognize here that the coefficients of my x squared and my y squared are the same, and since they're added, that this is going to be a circle, but it might not be that apparent to you from this form. So what we're going to want to do is complete the square to put it into the standard form. So to do that, the first thing you're going to want to do is group the x's and the y's, because what I want you to notice is, unlike the parabola, we have an x squared as well as a y squared. So we're going to have to complete the square twice. So as I rearrange the variables here, I'm going to have a y squared, and then that'd be plus 6y equals negative 29. All right, so now what I'm going to need to do is go ahead and complete the square. Find the values that is going to create a perfect square trinomial for my x's as well as for my y's. All right, now remember, to do that, all you simply need to do is take the middle term, divide it by 2, and square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is going to equal 25. 6 divided by 2 is 3. 3 squared, let's write it. 6 divided by 2 is going to be 3. 3 squared is going to equal 9. Now I'm going to take these values and I'm going to add them inside of the parentheses. That is going to be that's going to equal my value c that completes the square. Just remember that once you add them to the left-hand side, you're also going to want to add them to the right-hand side. So we're going to have y squared plus 6y, and then we'll have a plus 9, and then over here we'll have a negative. Oops, let's go and clean that up. This will be a negative 29, and then let's see, we'll add a 9, and then we're going to add a 25. Now, when you go ahead and work through all of this here, let's see, you're going to get a 25. You'll end up getting a 5. Okay, so now we can go ahead and complete the square here. So let's see, this goes, let's see how this reduces. This is going to be a x minus 5, quantity squared, plus, let's see, a y plus 3, quantity squared. And then if you add all these up, that's going to equal a positive 5. Okay, so this would be a circle with a center at 5, negative 3, with a radius of the square root of 5. And that's just kind of, looking at, hopefully maybe you recognize that from our understanding of circles. All right, so I want you to see the difference here. Here I have an x squared and a y squared, so I know it's not a parabola, but my coefficients are not the same, right? And we're adding here. So my coefficients are not the same, and since we're adding, I know this is going to be an ellipse. That might not be apparent to you. So let's go ahead and complete the square. But I want you to see how the x squared and the y squared are, they have the same scalar, right? Technically. All right, so again, we're going to do the same thing. We're going to group the x's and the y's. So 3x squared plus 6x plus a 2y squared plus 4y. Okay, is equal to 1. Now in this case, we have these coefficients, and we don't want the coefficients. So I'm going to have to factor out these coefficients. So that's going to be 3x squared plus 2x plus a 2 times y squared plus a 2y equals 1. Now we're going to go ahead and complete the square again. So I'm going to take a 2 divided by 2 and square it. And that's going to equal a 1. And that's going to work for both of them, right? So I'll just do it twice anyways. Why not? 2 divided by 2 squared, and that's going to equal again 1. Okay, so now what's going to happen is it's very important what happens on the right-hand side. So we're going to add them into the parentheses, right? That's going to create my perfect square trinomials. But more importantly, we need to understand what's actually we're adding on this left-hand side. We're actually not adding a 1. We're adding a 1 that's being multiplied by 3. So when I add this 1 here on the right-hand side, I need to also multiply it by 3. And the same thing's happening over here. If I'm not really adding a 1. I'm adding a 1 via distributive properties being multiplied by 2. Okay? So, because if you were to distribute the 2 or distribute the 3, you would actually get a 3 there and a 2 there. So that's why we need to make sure that we multiply them on both sides. Now in this case, I can now factor these. So therefore, this is going to be an x plus 1 quantity squared plus a 2 times y plus 1 quantity squared. And then here, we're going to get the number 6. Now, if you remember from the standard form of our ellipse, they're always equal to 1. So what we're going to do is just work a little bit further here, and we're going to divide everything by 6 on both sides. Now, 3 over 6 is going to equal 2. So this would be x plus 1 quantity squared over 2. Plus, and then 2 over 6, that can reduce us to 1/3. So this would be y plus 1 quantity squared over 3. And you can see now how this is the equation of an ellipse. They both have their denominators that they're divided to. They're equal to 1. We have our h and our k, and they're separated by addition. Now in this last equation, again, we can see that we have an x and a y, and one has a coefficient, one does not. So again, and one we have something for y and one we do not. So it kind of looks a little crazy here, like what's going on. So what I'm going to do is let's just group here the x's, and then we'll group the y's. Oops. All right, 4y squared equals a negative 3. Okay, well, I need to complete the square here. So 4 divided by 2 and then squared. So let's say negative 4 divided by 2, quantity squared, and that's going to equal positive 4. So I'll add that inside my parentheses here. So I have a x squared minus 4x plus 4. Okay, and then we'll have a minus a 4y squared equals negative 3. All right. So there's really nothing I can do with the y, but that's fine. We'll just leave it. You know, that's possible to not have a, remember you can, kind of like over here, you can have just a y squared identified. That just means your k is going to be 0. So I will factor this down to an x minus 2 quantity squared minus a 4y squared equals negative 3. Okay. Oops, I'm sorry. I forgot to add that in. Guys, if you're going to add a 4 on the left-hand side, you have to make sure you add a 4 on the right-hand side, right? All right, so now this simplifies to a x minus 2 quantity squared minus a 4y squared equals 1. Now this is nice. It's already equal to 1, so I don't really have to do anything. Sometimes students will go ahead and rewrite this. Like you can see, this would just be a different form here. You could, if you needed to, rewrite them as another typical way to rewrite this, which would kind of sometimes can be confusing. But multiplying by 4 is the same thing as dividing by 1/4. Okay, so just another way for you to see that there is actually being divided by a number. Here, it's just that number is going to be 1/4. So sometimes it can be confusing, but I wanted for you to kind of see it. Typically, we will write it in this format compared to that one. But if you needed to identify your A or your B, you can see that the B in this case would be 1/4. All right, so that was a lot of work for some of the problems. And obviously, you could complete the square for the next set of 4 problems. But if we just did it, like why go through it enough? If we only need to classify the conic section, we don't need to actually identify the parts of the conic by putting it into standard form. If we just need to classify it, then let's just look at the A and the B. And the A and the B represent the coefficient of your x squared and your y squared. All right. Now, remember that the coefficients for if you have an x squared and a y squared, it can't be a parabola, right? Because a parabola only has one x squared or y squared. So in this case, we're dealing with either, not a parabola. I also noticed that my x squared and my y squared are both positive. Well, it can't be a hyperbola because the x squared and the y squared there's a difference between them for a hyperbola. So when I multiply these, I get a 4 times 1. And when we're equal, when you have a positive times positive is greater than 0, you can see that this is going to be an ellipse. Okay, so when they're both positive but they're not equal to each other, it's an ellipse. Now in this case, you can see that this one's going to be a parabola. Because I don't even need to rewrite this out, but I could write this as a 0y squared, right? Minus y plus 2x equals 7. So therefore you'd have 1 times 0 is equal to 0, right? But if there's only one x squared or y squared, it's going to be a parabola. For the next one, you can see that this one's positive. This one looks very similar to the ellipse, very similar. The difference here is my a and my b are exactly the same. So when you have them both positive and a is equal to b, then that's going to be a circle, right? Because it's not being elongated horizontally or vertically. And then the last one here is you can see that these are similar. It looks tricky. A lot of students will think it's going to be a circle, but you can see that one of them is going to be negative. And again, the product here, if you have 5 times negative 25, that's going to be less than 0, right? That's negative 25, which is less than 0. So therefore, that is going to be a hyperbola. So you can see that's a lot quicker if you just need to classify them and they're in your general form. Then just use your understanding of your coefficients. However, if you do have them in standard form, it is helpful to, or if you need them in standard form, it is helpful to go ahead and complete the square. All right, guys, that is it for your processes. I look forward to you checking your work and checking your understanding and seeing you in the next section. Cheers.